All right, let's talk about a molecule you've definitely heard of, dopamine. We all know it as the brain's pleasure chemical, right? But what if I told you that's only half the story? It turns out dopamine has this whole secret life, a double life, that goes way, way beyond your brain. So let me ask you this directly. When you think dopamine, you're probably picturing something happening deep inside your skull, right? Some brain chemistry. And yeah, you're not wrong, but is that the only place it's working? As we're about to find out, the answer is a huge no. Okay, so let's dive into dopamine's secret identity. For a long, long time, science just assumed its role outside the brain was, well, pretty minor. But as we're going to see, some groundbreaking research revealed it was a major player all along, hiding in plain sight. And this right here captures that huge shift in thinking. The old view was pretty straightforward. In the body, dopamine was just an ingredient, a step in the recipe to make another chemical called norepinephrine. But then, back in 1984, some researchers put forward this pretty radical idea. They said, hold on, what if dopamine isn't just an ingredient? What if it's its own independent messenger with its own massive network running outside the brain? Now, you can't just make a bold claim like that without some serious evidence. So, researchers went looking for it. They started measuring chemical levels all throughout the peripheral nervous system, trying to see if dopamine was really doing its own thing. And what they found was pretty mind-blowing. And this is the data that changed everything. Look, in a lot of these nerves, the dopamine levels are just a fraction of the norepinephrine. That totally fits the old ingredient theory. But then you get to the vagus nerve. At 119%, there's actually more dopamine than norepinephrine. Think about it. You can't have more flour than the cake you baked with it. This was the smoking gun. It was proof that dopamine had its own separate job to do. And it's not just one small job either. This peripheral dopamine system is everywhere. We're talking about it helping to regulate your heart, your gut, even your kidneys. It's this huge functional network running through your entire body, constantly sending messages back and forth with the headquarters up in your brain. So, okay, we've got this body-wide dopamine system, but how does that connect back to dopamine's more famous role in the brain, the one we hear about with motivation and reward? Well, the answer really comes into focus when we look at what happens when that whole integrated system gets hijacked. And that's exactly what happens in addiction. Researchers like Koob and Volkov have broken addiction down into this three-stage cycle, and dopamine's role actually changes in each one. First, you have the binge stage, where the reward system gets that huge jolt, but then comes the withdrawal stage, where the whole dopamine system crashes and becomes underactive, which feels awful. And finally, there is the preoccupation stage, where just the thought of the drug can release dopamine in your memory circuits, driving that intense, powerful craving. And this gets to a really fascinating point. It turns out dopamine isn't really about pleasure itself. It's more of a powerful learning signal. Groundbreaking work by Wolfram Schultz showed that dopamine neurons go wild when a reward is better than you expected. If the reward is just what you thought it would be, they don't really react. And if it's worse, their firing drops off. It's a system that's constantly updating our expectations, and addiction completely distorts this learning process. And this chart, this shows one of the most consistent, most replicated findings in addiction science. On the left, you see the typical level of what are called D2 dopamine receptors in a part of the brain called the striatum. But on the right, in people with addiction, those levels are way, way lower. It's like the volume on their dopamine system has been turned down, making it so much harder to feel pleasure from everyday things, and driving that search for something more potent. So this brings us to a huge question. How do you treat this? If the system is so profoundly out of balance, not just in the brain but across the body, how can you possibly fix it? This challenge has led to some really new ways of thinking about the problem. You see, the goal is shifting. It's not just about blocking dopamine or trying to flood the system with more of it. The new goal is to achieve something called dopamine homeostasis. The whole idea is to find ways to help the body's natural ability to repair and rebalance itself, to restore the system to its optimal state, instead of just pushing it around with powerful drugs. And this quest for balance is partly inspired by theories like reward deficiency syndrome. The basic idea here is that some people might actually have a genetic predisposition. Maybe they're just born with fewer of those D2 receptors we just saw. That kind of blunts their whole reward system from the start. And this can make them more vulnerable to seeking out really intense experiences, like substance use, just to feel, well, normal. And all this leads to these really different philosophies on how to treat the problem.
You've got what you could call the blockade approach, which uses drugs to literally shut down dopamine pathways. Then there's the overwhelm approach, trying to flood the system with powerful substitutes, but that can sometimes backfire. And then you have this emerging balance approach, which is all about gently nudging and nourishing the system back towards that healthy homeostasis. So this really brings us full circle, doesn't it? We started with the surprising discovery in the nerves of the body, and we followed it all the way to the complex world of addiction in the brain. It paints a much richer and honestly a much more complete picture of what dopamine really is. In the end, it all comes back to that simple but powerful conclusion from that 1984 paper. There is a huge dopamine system spread throughout our body, outside the brain. It was there the whole time, and understanding it really changes everything. So, from now on, when you hear about dopamine, I want you to try to forget about the simple pleasure chemical idea. Instead, think of it as the body's universal motivation messenger. It's the chemical that connects the main headquarters in the brain to every single regional office in the body, making sure our mind and body are always on the same page, driving us towards what we need to survive.